Okay, so this lesson is going to show you how to raise I, let me write that down, to different powers. Okay, so let's talk just about what the heck I is first. I is the square root of -1. Okay, it's literally, it's just I. Okay, now if I take I and I square it, what I'm saying is I'm multiplying I times itself. In other words, I have the square root of -1 times the square root of -1. And you already know that if you take, or if you have the exact same thing under the radical, and you've got a pair of them, they come out from under the radical. So this is just -1. All right, let's raise I to the third. Okay, so you know that that's I times I times I. So we just a second ago said that I squared is -1. So that means these two i's right here is actually -1. -1 times I is just -I. All right, and then if we had I to the fourth, okay, so you know that that's I times I times I times I. Well, again, if I squared is -1, that means that's -1 and that's -1. -1 times -1 is just 1. Okay, now this is kind of where it gets interesting. I know so far you're like, yeah, well, so what? I don't care. I to the fifth. Whoa, what the heck? Sorry, don't know what's going on with my screen here. If I write I to the fifth, okay, so that's 1, 2, 3, 4, 5 i's. Okay, I to the fourth equals 1. That means these 4 i's equal 1. So this is really just 1 times I, which is I. I to the fifth. When I take I and I multiply it times itself 5 times, that just equals I. All right, if I do I to the sixth, and again, let me kind of write this out so you can kind of get a feel for this. 1, 2, 3, 4, 5, 6 i's. But every 4 i's equals 1. So this is really 1 times I times I. Now remember how up here, right here, I squared is -1. So now this is just 1 times -1, which is -1. Okay, so what if the numbers get really big? Okay, so what if it's like I to the, 26th? Okay, I suppose we could actually write all of those out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Right? And we can circle every 4 i's, right? So there's 4, and there's 4, and there's 4. Right? This gets really tedious and really annoying really, really fast. All right? But you can kind of see that all those things that I circled, those all equal 1. And all that's left here is I squared, which equals -1. The smarter way to do that exact same problem is let's rewrite I to the 26th a different way. I think you'll agree if I raise I to the fourth to the 6th power, that's I to the 24th, right? That's I to the 24th, times I squared, that's still I to the 26th. But I know all of these I to the fourths, right? All of these are 1. I don't really need to worry about any of this. I only really have to worry about what's left over once I take out the groups of 4. So let's see what happens. Let me see if I can move this up. Here we go. So if I raise these to like really large powers, okay? So what if I said, hey guys, I want you to find I to the 300 and... Actually, let's do I to the 301, all right? You don't want to have to write out 301 i's. So what you're going to do is you're going to divide. I know that 4 goes into this evenly all the way up to 300, right? I can chunk 300 i's into groups of 4. All that's left, right? All that's left is 1 extra I. The answer to that problem is just I. Right, let me see if I can do this for you. So that's the same thing as I to the fourth. Let's see, how many chunks of 420? 75 of them? 425. I think that's right. Let's see, what is 75 times 4? 2283. Yep, that's 300. So this is 300 i's and then 1 more. All right, hopefully that helps.